All right. Mic check. Testing mic. All right. I see the volume is, I can see the signal that actually picks up my sound. Um, I'm actually putting this recording together after our last session because while I have the video for the last session, the audio was not great. And so I decided to put this together to recap the key concepts we discussed in session two. And it's my fervent hope that technical bugs that have plagued us as we've attempted to record these sessions is going to get resolved. My apologies. So for session two, if you want to review it, you can watch this video as a recap, and you can also watch the video without the audio if you're so inclined. All right. I'm going to quickly review. Let's see here. What do I have? All right. So in the last session, I did mention to you guys that I was going to make an attempt to, review or at least document a bit better some of the stuff we're doing for future, right? So, and for your own benefit too. So, I presented this outline as a sort of our guide for the session, and effectively, we are at this pace or at this rate, at the rate at which we're going, we need to be doing a lot more SQL querying. So, the focus for the session was on how we're going to really do a lot of querying, writing, and more interactive writing. So I was going to give you guys a lot of examples. And so this session will recap what we did in terms of that. So the key areas that we're going to focus on were how we use in-app queries or views to make our queries better and build on our knowledge of joins, and then some of the statistical analytic functions that we've been looking at. We'll start from the general structure of a query. All right, the query starts off with select some fields from a table or some tables where some join condition is being applied or some filtering. So if, let's say you want to filter, say where maybe ID equal to something, this will come in the where section. The group by is used when you have to do some analysis of your data by categories. So if we are interested in saying how many, using the example of the data we've been working with, if you're interested in figuring out how much salary is being paid for each department, then the group by section will be used. Order by is typically applied after the entire result set has been returned, and then the presentation of the results on your grid would show it in the order in which you want it to be displayed, either in ascending or descending order by certain column or columns. Okay, all right. So we'll start off with what is exactly in a query, and my little description I put here is that if you think about it, an query is something you use to capture a result set that you plan to use later in your query. That's the simplest definition I can give to it. So we'll do a lot of practical applications of this today, and that hopefully would confirm, or at least give you ammunition to confirm that concept. Then we'll review some of the joins, the inner, left, right, full, and self joins. These are things we've already done, but I think of them as we now have a collection of tools in our arsenal, and we'll be using these tools to solve different problems, right? So this is more for documentation. Inner join, we talked about how you just join a table and you only want results to be returned for those cases where there's a match on a key that you're joining on. A left join, you're basically saying every result that is from the left table should show up, even if there's no match on the right side. And a right join is the reverse. You want every result on the right side to show up, even if there's no match on the left side. And a full join is saying whatever is on the left, even if there's no match, show it. Whatever is on the right, even if there's no match on the left, show it. And then we talk about a special case of a self join, which is joining the table to itself, which you can implement using either the inner, left, or right join. Some people try to do it full joins. I've never really understood why you would do it, but in theory you could. Then we'll finish it off with a bit of a dive into the group by clause, and actually that's a very important area. Um, One area we would be exploring after today's session would be how we can actually use some of these Oracle special analytic functions. There's a very good documentation online. So you can feel free to visit the site. And so if you want to know more about it, we would go through it. I would give you a few examples on that in session 3, and how we can actually leverage that to reduce the amount of coding we have to do. But before you can actually understand this Oracle special analytic functions, you really have to know the basics, right? That's why I want to take us through how inner queries work or inner views work, and then how we can build our query block by block and then get our result set. So hopefully that's a good agenda to guide us today. And this recording doesn't feature your questions, so I'll try to paraphrase some of the questions that I made notes of and use that to highlight at least some of the key points. All right, so I'm going to go back to the presentation and switch to sharing the SQL developer window. Okay. In session 1, I gave you guys an assignment. And the assignment was to build on something we had been working on up until, towards the end of session 1. So we looked at how we can use some of these functions that Oracle has to do some statistical computation. I'm going to format this result so that it's a little cleaner. All right. So just in case you're wondering, the way you format it is you highlight the query and you know up to where you want it to end, and you right click and you select format. For those of you who are keystroke inclined, you can use Control F7 to get the same effect. But I will click format and it will format it. When you do that, it does line up things very cleanly. Now this highlights the whole inner query or inner view or onion, as I like to call it, the layers of the onion. So for session 1, we created this query where we looked at how do we get for each department the total salaries being paid to that department, the average salary, and then how many employees were in that department. So I connect to my database here. Okay, there we go. Took a little longer to connect here because I restarted my before this session. All right, so if you just run the inner part of the query, you see that it's showing us for each department ID the salaries that is being paid to each department, and the average salary, which is not formatted at all, so you have so many decimal places, and then the total number of employees in each department, right? One of the things that is interesting about this result set is that because we plan to use the sum of the salaries and the average of the salaries and the number of employees later, we had to give it an alias, right? So in aliasing, my recommendation or advice is to be consistent. And if you plan to use a field, a result set later, your best bet is to use underscores to help create a column names. So if you can use something like as, use something as this, sal by department. But the problem is if you plan to refer to it later, it's very, very painful. And in fact, I've never really had success doing it that way. So my recommendation is if you plan to use it till later, you do that. Now you do this version as double quotes, some description and double quote in your file if you plan to display this nicely in your final result set. So I'm just going to do that to this cell by department, and you should watch what happens to the second column in the result set. You will notice that Now it's a sell by department. So if you plan to say this, show this to your boss, I'm saying you do it for somebody and they want a lengthy description for the column, then you want to do something like that. Okay. This is just more of a formatting issue. And so I generally say when you've all said and done, the very outermost layer of your query is the one that you should be using these as sort of concepts, because that's what you're going to eventually present to your client or your end user. So kind of just uncomment this line and just go back to this. So this is all a recap from session one. And in session one, we did talk about the different tools we have in our arsenal, right? So a table is a database object that we have in our arsenal. So what is a table used for? We use a table to store data, right? And so one of the things that I want to highlight is that the logic or the way SQL queries work is that you think about how you will ask a question to somebody. You say, I want you to go to get me tomatoes and onions from the supermarket. So you say, think of it this way: select tomato, right, and onions or bananas from ShopRite, right? That's a way in which you would frame that request. So SQL actually is very, it tries to kind of, it's structured in such a way that allows you to kind of think about things very simply, even though it's still very technical behind the scenes what's going on. So the structure is select a bunch of fields from some tables. In this case, it's just one table, which we've given it an alias of an E. And because in this particular case, we're looking at each department giving the total salary or the average salary and that sort of information, then we have to use the group by. Okay. All right. So if I highlight this and I run this, we get the result that is at the bottom. Now, I did mention that this is not formatted, the third column, the average salary. So we have to clean it up down the road. But for internal results, I think queries that are within your inner query, you don't have to worry about formatting. Most of the formatting you want to do should happen in the very outermost query, right? Because if you start formatting your numbers, unless you have a business case to do it, if you start formatting, it's going to throw off your final numbers at the end. So, for example, if you round off the salary to like one decimal place, for example, or two decimal places, and you had to use that average salary and multiply by something else in the outermost query, mathematically, you're going to start introducing a lot of errors, right, into your computation. So you generally don't want to do that in terms of like applying formatting to your output and until you're really at the outermost query. So to highlight that point here, I'm going to go highlight this query where I'll pull this average salary, which is currently not formatted, and I'm going to call the round function, which we've been using to format our result set. So the way it works is you call the round and you supply the field that you want, you put a comma after that, and you will specify the number of decimal places that you want, right? There are other things that I'm doing up there, but for the interest of just highlighting the format, let me just run this. And then you should see that now the average salary, if you look at that, that's the last one in the outermost query, is formatted to two decimal places, right? So we don't have a lot of this .33333 stuff, okay? Now, there's a lot of formatting you can do when it comes to SQL, and round is more of a mathematical rounding that you're applying. So somebody could say, well, why am I not seeing 9500.00 or 4150.00? Yes, there are ways to do that, but that's not the purview of this particular session. For this session, just think of using round to help us simplify our formatting of our numbers. Okay, now, sort of building on the concept of this inner join, right? This inner query. The inner query, again, is just this portion of the query, right? When you format it, like I said, SQL Developer, which is a client that helps you interface with an Oracle database, um, uh, does help you kind of see visually where the inner begins and where it ends. In this case, you only have one inner layer, right? So it's indented the parenthesis, the open brackets, so to speak, and it's clearly identifying that section as the inner query. Okay. Now, recall that once you have an inner query, you give it an alias so that you can refer to it again later. From session one, once we got our results set, we said, okay, why do we have the department IDs here? And there's the cases where it's a null department ID, and we said, okay, how do we make sure that we show not just the department ID, but we actually do show the actual department name. And then the tool that we know of is whenever you have to do a lookup by some field to get the actual description, we do a join. In this particular case, we have to do a left join of this temporary or inner query or inner view with our departments table, right? Departments table. If I'm just to describe that, let's do a pop-up describe here. It has columns like department ID, department name, manager ID, location. Since it has a department ID, we can look up the department ID and get a department name. Okay. Let's cancel this. And so we know that we can join our inner query, which has the department ID, with this HR departments table on the key column. Now we use a left join because we want the null department IDs to also show up, because there are people who do not apparently report to a particular department, which is a whole different issue to discuss. But for now, we want to include that in our final results. So we are going to use a left join because we want everything from the left side to show up. If I actually was to kind of highlight this a bit cleanly, I would move the alias down a bit and try to use the format that we've been using, which is your left join, right? And this visually tells you that everything from this left table, right? Now we say left table, but I understand that an inner query or an inner join is a result set, and a result set is, for practical purposes, a view. And that view, you can think of it as the data in some table, right? So there's a virtual table, right? That's one way you can refer to it. And you can join that to any existing actual table, right? So we want everything that comes out of our list of departments and the salary by department and the average salary and the employees by department. We want everything here to show for what the department name. So that's why we use a left join. Okay. So the structure is, this is our left quote unquote table or virtual table or inner query, and we want to left join it with our actual departments table on this important condition, which is we want you to join on the department ID. Okay. So putting it all together, if we put the joins together, then now, because we gave the HR departments an alias of D, we can refer to department name from the HR departments. And if everything is being coded correctly, if I run this query, we should see for each of the departments, the actual department name, the employees by department, the salary by department, right? Let's see if our null one came. Yes, so our null came in. And that's the point about it, right? It's there was a null in our result that said, okay, some null department was having a total salary of 18,500. We still want to show it in our final result because guess what? All these monies are going out, right, to people. So if you're doing an audit, you need to know, okay, hey, where is my money going? Otherwise, you'd be off, right? So that's the power or the importance of using a left join or a right join to highlight rows that otherwise will be hidden if you used an inner join. Okay. So effectively, that was what we built into by the end of session one. And I gave you guys an assignment to modify this query to then now that we have the salary by department, to then actually give us for each of the salaries. So this 19,000, what is that in reference or relative to the entire salary for the firm, right? So I'll move over to our guidance materials for today. And how do we solve that problem? Effectively, what we have to do is to let me connect to my database again in this worksheet. And is that I'm going to pick the inner query and I'm going to sort of build it again so that we all see it, right? So if you pull the inner query and you run it, again, this is the same result like we've been looking at. It just shows you for each department, the salary or the total salary being paid in that department, the average salary, and the number of employees, okay? This is a query in of itself, right? You're selecting a bunch of fields from some table and you're grouping by. That basic structure of SQL will always exist. Select from, okay? Really, at a minimum, to select data, you need to use select from somewhere, right? All the other stuff about joins and all that comes in per business rules and requirements. Now, one key point to note is we're selecting, this is an actual field, department ID. It's an actual field in the employees table. So I want us to kind of quickly explore this employees table a little bit, okay? So I'm going to browse through, or I'm connected to SysDBA, right? All of you have access, and at SysDBA, you have access to every single account. And at SysDBA, you get to see all the users, right? Now, a user which does not have the ability to create a table or a view or any database object, but just simply can connect and browse data, is typically a general like user. So if you join a company and they create an account for you to connect to their database, it's simply a very basic user setup they'll give you. And especially in production systems, they wouldn't give you the ability to kind of create tables. It's users who are created as schemas, which is people, IDs that have the ability to create objects, are the ones that you will typically refer to as a schema. So um, sort of two distinctions there. However, the concept of a schema is very powerful. The concept of a schema allows a very expensive database server to be shared across multiple teams in an organization, right? So that you can create that isolation. So if I have an organization with 5 divisions, and I can buy one database server, and all 5 divisions will have access, right? However, each division can have their own schema. So if division 1 has about 100 tables they are using for their stuff, we'll create one schema called division 1, and they'll have their tables. Division 2 will also have their own schema, and none of these will see each other unless explicitly you grant access to specific tables, right? And then that gets into the area that I know Andy was interested in our last session about what is a star schema versus a snowflake schema and what have you, okay? So HR is one schema. So let's think of HR as a division in our company, right? The HR department, and they handle all the hiring and firing and logistics and benefits and all the administration, immigration, all the other stuff for the company. So they have their own schema, right? And they've created some tables. We've reviewed all these tables before in session 1. And right now, I'm just going to quickly browse through the employees table again, right? Just to recap what we've been looking at. So the employees table has 11 columns: employee ID, first name, last name, all these things. Note the data type that they're using, right? So the employee ID is a number type. It's not nullable, as in you cannot put an employee into this table if you do not provide an ID, okay? And in the previous session, I think Andy mentioned sequence. Yes, a sequence is actually a very useful database object you can use to automatically assign some unique ID for every transaction you have. So if anytime an employee comes in, which is like you're recording an employee record, it's a transaction. You're saying this new employee has come in, right? It's an action, and we have to give that employee an ID. You can use a sequence object. And if you're interested, we can get into more details about that. It's very good material. You can just Google that information. After this course, you'll find out that you'll be equipped with enough tools to basically go on any search engine and type concepts or ideas that you want to explore, and you should find a lot of um, helpful material about it. And you should be able to read it and understand it yourself. Okay, so we have the employee ID, and it's a number, right? Using 6 digits. The first name is a varchar2, which is what we learned is a text field, and it can take up to 20 characters. Yes, it is nullable. You can actually put somebody in your system who doesn't have a first name. I don't know how that is possible, but you could. Now, the last name is not nullable, okay? And email in some of these other fields. One important utility or tool that the SQL developer tool gives you is that it's very rich at showing you how you write SQLs. So a lot of times you can learn how you write SQLs by just going to the SQL tab and clicking that, and it will show you. So in this particular case, how this table was created was it was a create table in schema HR, and the table name is employees. And here's a list of columns. Okay, there are a lot of concepts we've been talking about, like, okay, how do you make sure that the column cannot be null, for example? So here it says constraint, not null, enable, meaning that this last name, you can never put a null when you're making an entry into it. Because null means I don't know, right? And if you want to have a list of people working in your company, you better make sure at least they have a last name. You can't say I don't know my last name, right? So whoever is going to enter data should at least provide a last name. Okay, so that's the structure, right? You can always refer to this to learn more. There are other constraints like check constraints, for example. Here is a constraint that says that if somebody is going to enter your salary, it always has to be greater than 0, right? Meaning that if you enter somebody into the system, you're going to put a salary number here, then that salary number has to be greater than 0 because per law, you cannot just hire somebody and not pay them any money. Unless, I guess, you're coming in as a CEO level, in which case you pay them at least $1 salary. For political reasons, people do that. A point I was going to highlight to you, though, is when you create any column, you can put a comment on it for reference down the road, right? So let's look at how they put a comment on the field phone number, for example. You say, comment on column HR.employees.phone number, and phone number of the employee. Basically, the comment is that's the phone number of the employee. It includes a country code and the area code, right? So down the line, if somebody wants to look at the data, they can say, okay, hey, this column phone number is actually representing the phone number of the employee, and it does include a country code. Okay, so if you inspect the data and it doesn't have a country code, you say, hey, maybe something is wrong right here. Okay, but that's how you put a column, a description or a comment on a given column in a table. Additionally, this is how you create an index on a table. You will see things like percent free init trans. We will explore that probably in session 4. But for most part, these are sort of, you take the default values that Oracle gives you. It's just Oracle's way of trying to configure your table or your indexes or your objects in such a way that they're efficiently designed to use the storage that you have for your database. Okay. And some of this concept is done to help you, like if you have data that you're going to update in, some of these values may be a little different, like percent free and those sort of things. But for now, that is more like a DBA level of information, so I would exclude that. General things, if I want to create an index, this is all I need to create an index on the table, right? I say create index HR, and I give it some name. And remember that any object that you're going to create in the database, the length of the object, the name that you're going to give cannot be more than 30 characters. So you say something, try to use, I think you use under 30 characters to describe a name of an object. You have enough to kind of come up with any name that you have. The convention people use is somebody can say, hey, every index I create will end with IX. some people will prefix it, and so I would like to create all my indexes and say, instead of hr.emp underscore department underscore ix, they will use hr.ix underscore emp underscore department. Whatever version you choose, just be consistent with it, right? So in this system, all the indexes, right, they're using ix to end all the index names. And it's very useful because down the road, when you're browsing or researching the data, it's easier to say, okay, hey, here's all my indexes. Okay. There's a bunch of other objects like triggers that are existing on this table. And, we would definitely talk about triggers. I think I have it scheduled for session 4. Let me quickly look at the general layout for I think, let's see, hold on. Yeah, so I have triggers scheduled for, let me see here, it's for session, yeah, it's for session 3. We may touch on it, it may be session 4, depending on how things progress, okay? Now, let me check to confirm these two through my screen. Good, all right. So again, the whole reason why I took this sidebar here was to highlight that if you ever want to learn how to create object types in your database, this SQL developer tool that you have is actually going to be very, very helpful as a reference. You look at some of the existing objects that are created and you can see. So for example, if I want to learn how to create a view, if I double click the view and I click SQL, it would actually show me the SQL generating DDL, generating the data definition language, DDL, that's what it stands for. How is this view defined, right? And it clearly shows you that is create or replace force view, meaning that if the view does not exist, create it. If it exists, replace it with the new definition I'm going to give it, right? And this is the syntax of how you create a view, right? So down the line, if you plan to create a view, you will learn, you don't remember the syntax, you can actually just come here and look at it, and you can learn a lot more from it that way, okay? All right. End of the sidebar. Let's go back to our session 2. So the reason I went there was to show that, okay, all right, we have this employees table, and this employees table has data showing for each employee how much salary they're making, okay? And if we look at this data set, okay, you think about it and you say, all right, if the database was trying to figure out for each department, if you submitted a query that says for each department, give me amount of total salary for each department. The way you kind of logically go through it would be to first of all sort by the department ID. I'm gonna kind of drag this so that I can see the last column here. All right, let me just shrink this column a little bit. Employee ID. Okay. So if you had Excel spreadsheet and you're trying to visually solve this problem, the first thing you do is, okay, let me group or sort the data by department ID. So I have 2 people in this department, right? And I can visually see that, okay, the total salary for department 20 is 19,000. Let's do a quick check to see what we got, right? So department 20, yeah, total salary is 19,000, right? So we're looking at this. This is a very small set, 108 rows or whatever, right? If you're dealing with millions of records, you can't do it that way. But the steps or the logic in which a query will be executed is that we say, hey, get all the data that the user is interested in first. So select from some table. So let's go to that table. And the user wants to do some analysis, like the user wants to group the data by department ID. Now, grouping basically means let's put all the adjacent data that is adjacent to each other should have the same department, right? So you say department 30, they're all together. Department 40 is all together. Department 50, quite a bunch of people in department 50, they're all together. Only one person in department 70, and a bunch of people in department 80, and what have you, right? So Oracle would kind of fetch the data, group it by these departments, and then we'll go through and compute the total salary this way. Now, with it would sum this, and for 30 it would sum this, right? Then for 40 it would sum these two, and um, that follows to the very last grouping of department IDs. The essence of it is, once it's first show the data from employees table and it's grouped it, then you're saying that for each department ID, I want you to give me the sum. I also want you to give me the average. I want you to give me a count. Now, you may say, well, why am I doing a count star here? Why don't I do, because count star, what does it mean, right? In actual sense, in this particular example, I did highlight that we can use an alternate way of doing it, and I'll bring that to our attention very shortly, which is we can, instead of doing count star, we can actually do e dot employee ID. That's a much more, it's better because you count the number of employees in that department, right? So sum and average and count, they are all aggregate functions, right? And you sum the salary, that makes sense. When you take the average of the salary, that makes sense. But you cannot really count the salary per se, even though that can give you a number, right? The best thing is you say, okay, I want to count the number of people in that particular department. So it makes sense to use e.employee ID. So when we run this query, we're going to still get the same count. That doesn't affect our result, but it's easier to comprehend or understand down the road, okay? So, you can use count star as a short way of doing it, or you can use count.e.employee ID, and that should still give you the number or the answer you're looking for, okay? All right, now what are we trying to solve here? The assignment was, let's go figure out for the salary for each department, let's figure out that ratio of the salary to the department. So let me quickly dim up a little calculator that comes with every computer here, right? So if let's say the total salary for the company was 500,000, okay, as the total salary, and one department is paying 90,000, then that department represents this ratio, 90,000 divided by 500,000, which is about 18%, okay? But the key is we had to know ahead of time what was the total salary for that department. So the traditional way of solving this problem would be to, let's go figure out the total salary. So to figure out the total salary is very simple. Again, we go to our employees table and we say, select the sum of all the salaries for all the employees. We don't want you to group by anything, we just want the salaries. So it's a very simple one. You just select some salary from each other employees, and that will give us a total salary of, in this case, $702,916. Okay, I'm quoting dollars. That's assuming that's I'm assuming the company is in the US. Okay, so if we know this, the power of an inner query is I can use this inner query somewhere. So if I've created this, then in theory, if I got this value, I could divide it by this total salary. But before we get to that point, let's take some steps back to deal with a couple of issues that typically has to do with whenever you're doing aggregation or summation of numbers. So I created this query, and before we got there, I said, let's consider what happens when you have null with your data. Because yes, if you're dealing with data, one of the issues sometimes you run into is that when you have nulls and you're doing summations, it can throw you off. So I'm going to demonstrate that to you. If I want to do 1 plus 1, I can use this special table in Oracle called Dual. Dual is a sort of a special table that allows you to do quick computations, right? You can use it a lot. It's very handy, and when you're doing when you're writing queries and you find that out down the road, you'll be using it quite a bit. I want to do 1 plus 1, right? So 1 plus 1 is 2, right? We say select 1 plus 1. Now, I mentioned earlier that null means I don't know. So what is 1 plus I don't know? Let's see. 1 plus I don't know is I don't know, because I don't know means I don't know. So what is 1 plus I don't know? I don't know, right? So that's going to give you no. So that means that whenever you're summing up data and you have nulls in it, it can actually potentially throw off your numbers. Now, one of the issues you see a lot with this stuff is sometimes you're doing some work on, let's say, SQL developer or code or anything like that. One of the issues I've seen in the past is sometimes these tools allow you, they do some behind the scenes cleanup for you, right? So you can submit a query, and the actual query they will submit to the database is a little different from what you actually see. So they may put some wrappers around the fields, and you may think, well, my query is coming back great. And then you go to production, you release your code, and it's not coming back well, because guess what? In production, you're not using SQL Developer or you're not using Toad. You're actually going to use what we call SQL Plus, right? SQL Plus is actually the main sort of core tool you use to interface with Oracle on the production system, right? To run queries and give you results. That's one client that you can use. There are other clients that are there from third parties, but the point I'm trying to highlight to you is that when you use this nice GUI or user interface here, uh, and it helps you write queries and it's beautiful and it's coming back, you have to pay particular attention to one of the defects that comes with these systems, which is they make some work very nice for you. They make your life a lot easy, but they can throw you off. So you have to really learn the first principle. So the principle I'm trying to highlight to you is that null means I don't know. The only time you do 1 plus I don't know, it can mean I don't know. Okay. So the nice way to Oracle gives you a way to handle that. So the way that handles that it has a special function called NVL. NVL basically takes the null value and replaces it with whatever value you want to use. This is a very important, useful function, but you have to understand that it's typically somebody in the business that's going to tell you what the rules should be. Because if you're dealing with salaries, right, and you're saying that, oh, I want you to go and sum up my salaries, but if the salary is null, use zero, that actually is problematic. As we saw earlier in the employees table definition, there is something called a check constraint that has been defined on the table that does not allow you to put any number less than zero. So if I go into this table and, for example, I was to try to change this 13,000 to, I would say, like the negative 2,000, we should get an error that the check constraint is violated. So I've changed the number. I'm going to hit this green sign to commit it, and it should give me this error. It says, I cannot update this table to negative 20 because negative 2,000 because the check constraint has been violated. Yes, the rule is there. The rule says when we create the table, we put the rule that nobody can put a negative salary in here, right? So it's not going to take my change. So I'm going to refresh this, and it says, okay, and say, yes, I don't want to save the changes because, you don't accept negative values. Is that understood? I hope this point is very clear. Meaning that, right, if I plan to use zero, that's it's not really a good value to use zero. But for the sake of our discussion, you know what? One rule the business person can give you is, if you ever see that somebody's in your system and they have a null salary, which really shouldn't allow you to do that, maybe you should go and get the average salary for that department, right? So maybe you look up the person's department, the job ID, and then go into I think there's a job code, and each job code table has, for each of the job codes, the minimum salary or the max salary. So they may say, hey, just put the minimum salary for that job code as the default value. Okay. For our discussion and our analysis today, we're just going to use zero just to highlight the point that we can use NVL to remove null values or I don't know values from our data whenever we do a summation. But please understand that somebody from the business, a business team, typically should provide guidance as to what the default value should be if null exists in your data. argument's sake, let's use 1,000. We can later on maybe learn how to, if you're interested, learn how to actually use a query to figure out what the default value should be in that particular scenario. Okay, and that actually could be a very nice project to work on in session 3. Okay, which is you know what? Let me just make a note of that. Use in a query pull default salary based on the job ID. If ever that person's job has a null salary, we're going to figure out a way to do that. We'll do that in session 3. Okay. Okay. And let me put this here. But the key here is what? The key that I'm highlighting to you is dual is a temporary table that you can use to do your computation. And that null, 1 plus null, or null is an unknown. So anything plus unknown is unknown. But if you want to use a default value for your unknown values, you have the NVL function to use. Okay. So going back to this query that we started off with, right? We can do some cleanup and basically say during our summation, if we find a salary to be null, we're going to use 0. Okay. So this is just simply converting. Let me just try to bring the two in focus so that it's easy for you guys to see watching the video. Is that this line here, line 3, right, has been enhanced to, in line 20. Effectively, all we're doing is we're transforming the salary, and whenever we pull the salary and it's 0, and when it's null, we're going to use a value of 0 as a default by calling the NVL function. So we apply that to all the rows. Every row, we pull the salary, we check is it null, and if it's null, we use 0. Then once we have done that, we can apply the sum, okay, to it. So then when we sum it up, we're never going to have to worry about a case where a particular employee salary is null. Okay, we can do pretty much the same thing with the average. I'm basically here transformed the query, the average salary, to actually run it to 2 decimal places. But in theory, we could do the same thing here and say, hey, let's do NVL of the salary and then put a 0 just in case, right? We kind of nest in here. Don't get too confused by it. All we're doing is NVL is a function, so we wrap that function. And once we're done, we say, okay, take the average of this, right? So one of the nice things with SQL Developer is once you click on a given parenthesis, it show you where it's closing. And the last function is the round function. So we click round, it shows you we are closing here. The other light blue highlighted closing bracket here, okay? So at this point, we can run this query. It's still the same base query we're working with, but it's at this stage much cleaner, much simpler, and visually more stunning, okay? Now, yeah. So we can build upon this. Now, as I highlighted before, if you plan to use this query down the road, you have to use this underscores to help you identify the column names, which we plan to do. So, we're going to use the underscores to help. I do think it's generally a good practice to use more descriptive column names when you're creating this, so that helps you, right? So, in putting this together, I said total underscore salary by department. It's easy to look at it down the road to say, all right, this portion of the query is giving me for each department how much total salary is being done there. And similarly for average salary by department and then employees by department. One thing that I did here was to round it to 2 decimal places. And I just want to put a big caveat here that effectively we're saying that, when you take for each of the salaries for each department and you take the average, you round it to 2 decimal places. It's typically, again, not a very good idea to round your in-app queries or temporary queries. You don't want to apply round functions to them unless you explicitly have been told by the business to do that. In this case, because we do not plan to do anything more to this average salary, at least for this session, we can round it here. But the recommendation is to really be fair, this rounding, and you do it in the outermost query, right? So ideally, the best approach, and let me comment out this line, would be to do something like this, which is, let's just do the average, right? And let's not do the rounding now because we plan to use it later, okay? And then when we run this, we can then copy this section, and that's what we're going to use, right? So moving down here, I'm going to remove, this is where we built into the last session, right? So in the last session, we basically said, you know what, for each department, we did this analysis, and then we said for each department, we were going to take, so let me just do what we just did and just highlight the point to you, which is because, again, we plan to use, because we are planning to use the, we may use the average salary. We don't want to do its rounding right away, okay? Now let me close this bracket and we should make it. So, and what I'm highlighting to you is you don't want to do rounding when in your queries unless you need to from the business. Sometimes the business need may actually demand that, hey, at this level of it, round it to some decimal place. So it's really in the world of finance where you're charging people interest and they're, you know, some of the mortgage interest is 1.25% or 4.25%. Yeah, that rounded has to be done at that level. But generally, you defer most of your rounding and you do it at the outermost query. Okay. So let's just quickly highlight this portion of the query. The query, it should give us the department, the salary, and whatever. You may see this -1 here, and it's because I'm trying to use this NVL concept to highlight the fact that, yes, if you have a null, you can apply it and use some value. So right now, you know, if we run this query, and I'm going to comment it out and use it and run this query without the NVL, you see that there are cases where the department is null. And if you do that, this -1 highlighted in row number 3 is going to disappear and it will become null, right? So you can apply the NVL function, and again, what's comment, and uncomment this line. And you say anytime there's null, I actually want you to use -1. Okay. So in the assignment I'm going to give you guys, you're going to have to apply. We're going to relax this NVL transformation so that you can do some left join or right join, whatever your approach is to handle this case. But I just want to highlight the point of if you have null NVL, you can use it to transform any column you want. Okay. So NVL, the department ID is null, use -1. All right. So we built our query, we had the inner query, and we said, okay, now that we have that, our objective is to figure out for each of the departments, based on the total salary, we want to get the that salary relative to the salary from the entire organization. So going back to this example, where I said if a department is making 90,000, or total salary in the department is 90,000, and the entire company is paying out 500,000 in salary, then that department represents 18%. So I made the point that we need to know ahead of time that the total salary, right? Which we did before. Scrolling up just a little bit, we just wrote this function, line 12 to line 15, and that shows us the total salary for the entire organization. Since we're doing subqueries and inline views, I want to show you how you can leverage that to do your ratio computation. It's not the most efficient way of doing this, but I want to highlight this because once you understand this, it's easier to understand the shortcut approaches of solving these problems, right? You have to go through this journey, in my opinion, to really fully understand the sort of the mechanics of writing SQL. And that allows you that when you're solving a given problem, you can go to a company, there's some SQL somebody wrote 20 years ago or 5 years ago, and you ask to enhance it or fix it. If you they might write it this way. So if you don't understand how to do it this way, and you start looking at it, you're like, why are they doing it this way? You don't really have any understanding why they do it that way, right? Now, the general approach is you say, we know this inner query, line 52 to line 62, is giving us for each department the total salary and the average salary and the number of employees. Our assignment was simply to say, pick the total salary in the department and compare it to the total salary in the organization. Well, what that effectively means is that if we are able to extract out the total salary by department, we just have to divide that by the total salary in the organization. And guess what? We just run the query. So if I highlight just this query and I run it, it's going to give me 702,916, which represents the total salary of the department. So this is your total salary within the department. So just as we did in the calculator, we need the total salary from the department divided by the total salary for the entire firm. So since this represents for a given department the total salary, I just divide by the total salary from that department. Okay. So we give it a name of salary ratio relative to firm. Okay. Now we will multiply by 100. Okay. To so that you show. So I'm going to show you how you double comment a line. I'm going to just double comment it before we do that. So let's see here. All right. So yeah, if we ran this query without this 100 multiplication, what are we going to get? So then I took a leap. So let me just take it one step back so that you guys see it before. I'm going to show two results. These relative all round to the next round. If we ran this query, it's going to show. It's showing the salary in that department and the salary as a ratio of the entire firm. Now this 0.07, you all know math, 0.07 is 7%. So here it shows a 7, right? It doesn't have the percent sign, right? There are ways to format and all that stuff. But the simple transformation I did here was to say, once we get the rounded value, let's multiply by 100. And that's what this section is doing, right? So, you don't want to do too much of it. You say, okay, this round is representing 0.07. If I multiply by 100, I can get it in 7%, okay? So that's what this is doing. Now, I want to highlight a useful function for concatenating two fields. And that function will be used to help us apply maybe the percent sign to our numbers. So before I get into too much into that, let me just quickly show you something about two chart. Now, create a column in a table, right? Let's go to this sort of jobs table that we're looking at. You see how this column is varchar 2 as the job ID, right? And min salary is a number, okay? Oracle has a function that can allow you to convert a number into a character. Now, you cannot combine a number and a character. So, for example, you cannot do select 1 plus test, right? Let's use our dual table. You cannot do this. They give you an error, something like about there's an invalid number or something like that. Invalid number because 1 plus a character test, it doesn't know what to do with it. It knows what to do with 1 plus 1 because they're both numbers. But if you say 1 plus test, test is a string. So the only way it would allow you to do it is if both of them are the same data type. Okay. Now somebody say, well, can we do then? Okay, just click the wrong button here. Can we do? Hold on, my number P is not on. Let me 1 plus 0. What do you think it's going to give us? You're like, oh, why did it give it to us? Oracle has a bias, which is it would always implicitly convert every test to number. So when we gave a test before, it tried to convert it to a number, and it couldn't convert test to a number. And that's why it says an invalid number, because trying to convert this test to a number didn't work. So it was, but if I give it 0 and I put a single quote around it to tell us that this is a text 0, it will first convert this to a number. It really will convert this thing to 0 behind the scenes. And if that is successful, then it can go ahead and do select 1 plus 0, which would be 1. Okay, so you can do this like this. But most of the time, when you have a field that you define as a varchar or a text field, and you store numbers in there, you can still sum them up. However, to be consistent, the approach is to do this. If let's say you really want to be sure, you can make sure that, hey, convert everything to a number. So if you can't get that conversion to be done, then let me know right away if it fails. So this one, it can convert the text 0 to actual number. Okay. However, if we have two strings and we want to put them together, so I can say test concatenated with 1. Okay. This first text and this one, right? I can do this. Test minus 1. I've concatenated two fields together. And during the video, and I think during the session, Nana had asked a question about, oh, can we do that for the first name and the last name? And I think I put the query together. Let me see if I have it. Yeah. So we actually used that Nana's question to highlight two things. One of which was we looked at the employees table, and we saw that earlier that the employees table, the employee first name can actually be null, and the last name cannot be null. So, if you look at it, I went in and let me sort by department. I changed the first name of this employee ID 100 to null, and the last name is Ken 2. For some of you guys, your system will be Ken, so let me just, I changed it to Ken 2 from session 1. I can just come over here, okay? And so when we pull the first name and there's null, we can actually make it as NA. So we're still using the NVL function to transform the first name into null. But importantly, you can concatenate. So the assignment is put the first name and the last name together separated by a comma. This is how you do it, right? You pull the first name, then you say, well, if the first name is null, use NA. Then you use the concatenated sign, 2 pipe characters, right, on your keyboard. It's typically above the Enter key, depending on if you're on a Windows platform. And you can access that using the Shift key. So you do Shift and sort of the backspace, and that will give you the pipe. You need 2 of them, and this guy. So in this case, you want to put a space after the first name, and a comma, then a space before the last name. And that gives us the search. If I run the query, we show us for this guy, the employee ID 100, we say his name is not applicable, space, comma, Ken, right? If I don't want, I can just put this, remove this extra space, and I can do not applicable, comma, Ken, okay? So that's the power of using this concatenate sign. Why are we doing all this? We did this because we got a percent number, and we want to put a percent sign at the end of it, right? So we know that if you have 2 text fields and the percent sign, for example, can be, is this guy, we can do select text concatenated with that to get the percent sign. But it's a text field. So if you want to put 2 text fields together, or if you have 2 text fields, you can put them easily together. You can actually put a number field, pipe it to this, but I want to highlight a very good general practice is if you want to put 2 field types together, or you want to add them, make sure they're both numbers. If you want to put 2 text fields together, use the 2 chart to convert both of them to a split of characters before you pipe them together or concatenate them together. Okay, so to use the percent sign, we would have to convert the actual number, that we got, and then we'll pipe it to the percent sign. So scrolling back up to our query, we remember we did the 100 times the rounded to get 7%. Let me rerun that part of the query so that you see it where we left off. You see that the 0.7 is transformed to 7 by multiplying by 100. Now I'm going to uncomment this whole block of code and highlight to you how this 100 line here, okay, I've effectively repeated it here. I have, but I'm going to pipe it to this percent sign, right, so that we get this. But to guarantee that my conversion is going to be good, I'm going to first convert this portion of it, the portion that actually does the conversion. Let me break this up into multiple lines so that you guys see it. The 100, this piece of it, I'm going to keep it on one line. And then I'm going to explicitly call toChar. The toChar, which is convert whatever this expression evaluates to, I want you to convert it into a character. And then once you've done, I want you to put a pipe sign, use the pipe sign, concatenate it with a percent sign, right, which is a text. If we do that and we run this query, we're going to get 7 space percent. Now somebody said, I don't like how this looks. All right, fine, we could do this. We can move this space and run that query. And now our 7 gets becomes 7%. Now since the text, you see that this one, the 7, which is the number, is right justified, but this now is a text, so it's left justified. Okay. Now, to highlight this point about rounding, about the average, and that we didn't round inside here, we can actually apply our rounding function here, and then we give it a nice alias, like as say that it's out of outside, right? We don't plan to use it now. We use it a nice description, average salary by department. Okay, and if I run this query, I can get something as beautiful as that. Now this one is very nicely, like, you know, initial capital, then average salary by department. So if this is your final output, you know, my recommendation is then at that point you would say something like as department E. Okay, and you can say as salary department, and you can say as you can remove this one out and then say as relative salary. Now we did all these intermediate steps to get there. So relative salary rounded, okay, and this would be, this can probably be, let's give it this one to another name of relatively salary. And this one basically is, it's still the percent, but we actually percent with sign. Okay, let's say percent with sign, something like that. And if we ran this, if no typos have been made and all the conventions have been followed, and I run this query, it says character identified is too long. Now, which one is very long? Oh, good. You remember this thing's about 30 characters long? I think this is a long one. If I paste it in my notepad, I can highlight to you why that is long. So view status bar is 34 characters long. So Oracle doesn't want you to do more than 30. If I drop this and say relative salary, let me remove a few PCT and say with sign or something, you know, with sign. Then now I believe I have less than 30. Let me check the notepad and see if I have. The first one ends at 34, column 34, right? Now if I put this here, it ends at column 27. So this is 27 characters. And if that's where the main issue was, this query should work. All right, just run this in business. Okay, so to kind of highlight and sort of format this final query so that it looks very clean, I'm going to clean out a bunch of the intermediate stuff that we did. And so they have a clean version of this query. Now, understand that I'm going to upload this file into our shared Google Docs folder. So I'm going to just do some cleanup. I'm going to allow Oracle SQL developer to help me here by highlighting the query and right-clicking and say format. Okay. Now, if I format it, it's going to do its own thing and break it up into a lot of pieces so that it's clean to read. Sometimes I don't like it because it's just too long to read. Now, you're going to see some of this hello, yellow or whatever, orange highlights. It has to do with general, it's basically telling you that the way you've written the queries is not really the best way to do it. Because it's not really, it cannot really parse out the query and format it very cleanly, okay? So that's effectively what we discussed. And I gave you guys an assignment, okay? The assignment was, and what the benefit of this recording is that now that we've done for each department, we've done this analysis for each department, the total salary in that department relative to the entire firm. We want to do this 2 steps. I want you to transform the query to actually get the department name instead of the department ID. Now, notice that we are using -1 for the null values, okay? That really shouldn't affect your solution, but think of it that you're going to do some join, lookup, a left join in this case is highly recommended so that we can pull for all of this result set here, 11 rows on my screen. We want you to go and pull the actual department name, okay? And if you can give me an assignment Tuesday before midnight, because our next session will be Wednesday at 9 p.m. If you can give it to me before at least before midnight, I'll spend time to review it and make sure that I understand your individual needs and try to address that separately. So please try to give it to me before. So that's your first task. The second task is we've done this analysis on the department level. I want you guys to do this on the employee level. So for each department, for each employee, find their salary, find that employee salary relative to their department, and then do that relative to the entire firm. Okay. The essence of this is to really help you develop your skill of being able to write queries. And use the general concept or structure that we've given to you, right, in this tutorial to make an honest attempt to try to solve this. Okay, hope this is clear. I am going to wrap up this session, and for session 3, like I said, we will do more of the querying because my objective is to make sure that you can really write queries. Once you're given a problem, you can at least make an honest attempt at trying to put the query together. Okay, and if ever you run into an issue, try to figure it out as best as you can. But this session or this tutorial is designed to help you be independent, right? And so while I would like to teach you or at least impart into you a lot of the concepts, and you could go for interviews and they'll ask you very simple questions like this NVL stuff I was talking about, and they can give you a query and they say, can you complete it for us? Right? NVL is one of those things that you have to understand a lot because they actually do use that to trick people on interviews. Okay, but this is a recap of what we discussed in the last session. It's my hope that it's going to be useful and the recording actually turned out okay. All right, thank you, and happy learning, guys.